Hello friends, in this video we discuss about a problem from continuous time Fourier transform, and the problem goes like this. So we are interested in evaluating the two integrals which are given here. So first let us evaluate the first integral and then let us evaluate the second integral. So to evaluate the first integral, we will take the help of synthesis equation of the Fourier transform, which is given by integral minus infinity to infinity x of j omega into e power j omega t dt d omega would be equal to 2 pi into x of t. Okay, so this is the synthesis equation of the Fourier transform. We will take the help of this. Now if you replace this t with 0, so we get integral minus infinity to infinity x of j omega times d omega would be equal to 2 pi times x of 0. So we will try to use this important result in evaluating this integral given here. Okay, so if you remember, so we have seen that the Fourier transform of a rectangular function from minus, let us say, minus a to plus a with amplitude 1, so this fellow will have a Fourier transform as 2 sine a omega by omega. So by multiplying the signal with 2 by a, or by multiplying the signal with 1 by 2a, so we get again we have the same rectangle from minus a to plus a, but we multiply the amplitude with 1 by 2a. So this fellow will have sine a omega by a omega as the Fourier transform. So let us call this fellow to be x of t and this fellow to be x of j omega. So clearly we can see that we can apply now this result which we have got here, and hence we can see that so integral minus infinity to infinity sine a omega by a omega, so this into d omega, so this fellow would be equal to 2 pi times x of 0, x of t is this for us, and x of 0 value would be equal to 1 by 2a, and hence this would be equal to 2 pi times 1 by 2a, and this simplifies to pi by a, and that is what we have seen here. Okay, now to evaluate the second integration, we will take the help of Parseval's relation, which says that integral minus infinity to infinity x square of j omega d omega would be equal to 2 pi times integral minus infinity to infinity x square of t dt. So again by substituting x of j omega given by this, we see that integral minus infinity to infinity sine a omega by a omega whole square d omega, this would be equal to 2 pi times, so integral our x of t exists only from minus a to plus a, and hence we will get minus a to plus a multiplied with 1 by 2a whole square dt. Okay, so this simplifies to 2 pi times 1 by 4 a square, 2 pi times 1 by 4 a square multiplied with 2a, and this simplifies to pi by a. So this can be easily seen by cancelling 1a here, and 2 times 2 is 4, and that will get cancelled, and what is left out is pi by a. So clearly we can see that we have proved that these two integrals will simplify to pi by a, and this result we get using Parseval relation. So hopefully you have understood the concept of Fourier transform and the Parseval relation. Thank you.